Well, I spent a fair bit of time running around the internet trying to find a schematic for this guy, and I didn't. And I think I know the answer why. This radio was made in Yugoslavia, and it was made for export to North America, to the United States, I would imagine. And I think there's probably limited information about it. Now, somebody's put together a real nice web page on this radio alone. Beautiful photographs, top, bottom, up and down, but no schematic. And the radio appears in Radio Museum, which is the European radio database, big radio database. It's in there, but no schematic. So that's really disappointing. No schematic means yikes when it comes to doing any kind of alignment stuff with this radio. Boy. And you know, there's like nothing showing on the top of this radio that you can like the IF cans are solid. Wait a minute, there's some holes in the back. What's that? Oh yeah, okay, so that's where the IF cans get adjusted through the back. Let's see, there's quite a few adjustments back there. Let's take a look at that. The radio is not plugged in, so I'm not worried about too much here. Oh, wow, okay, so let's take a look and see what we can see back here. Yeah, there's adjustments there, adjustments here, and adjustments there. So they're all packed. It looks like they're all packed in here. Anything through the back here? Doesn't look like anything goes through the back. And what about underneath? Ooh yeah, all these. All these are adjustable. Anyway, this one's so loose. Yeah, that's turned almost all the way out. Look at that. That doesn't look right. Well, we'll fiddle around here a little bit, but I'm always anxious about doing anything to a radio that has FM circuitry in it. Because FM circuitry is much more difficult to align, especially if you have limited experience, and I have limited experience at doing FM circuits, so winging it almost certain to bring about a bad result. AM, yeah, I'm not so worried about AM. So my problem with this radio would be what's AM and what's FM on it. That would be the challenge. It sure seems weak, like so many of these radios, so many older radios seem weak from these loop antennas. There'd be some kind of tuning adjustment. Oh, there's more adjustments down in there. They don't look very adjustable, frankly. Let's take a look at them here. Oh, look at right down through there. Lots of things, and of course here's the FM tuner, and it's got adjustments all over it too, which again I don't dare touch because I think all I can do is make it worse. So I can probably fiddle with these IF cans, except once again there's, oh man, there's 1, 2, 3, 4. They look waxed in also. Man, that doesn't look. Let's give it a little twist. Find out if these are even turnable. Come on. Oh yeah, it's I can tell these are locked in place too. let's play this radio again and just see if it isn't really actually in fine shape, and all that's happening here is I'm dealing with bad antenna down in the basement, all that kind of stuff, because the FM sounded quite nice on it. So let's see. We'll leave it turned around like this, so I got the back at me, exposed at me. We got to take a look at this magic eye also at some point. See what we can do about that. Now, get these clip leads out in the clear here. Make sure there's no short occurring over here. And let's get the power cord here. Power switched off. Volume's down. The radio is switched off at the moment. Okay, quick safety check. Put the light out here where we can kind of see it. That's always a helpful thing. Power on. Okay, now I'm going to turn the radio on to FM. We're going to start with FM. There it goes. Light came on. Just can't quite see it in your view there, so I'll just move it. There's the light over here. That'll keep me mindful that I've got power on to this radio. Okay, we'll give it full power, which today is 123 volts on my meter there. All is pretty quiet. Let's give it a bit of volume here. Totally quiet. Something not quite right here. I was hearing something. Yeah, so it's definitely a speaker connected. Okay. Make sure the volume is turned down. And we'll put an antenna on it, because maybe it's just going to do nothing unless it has an antenna. I think these banana plugs are a little small. No, they'll do. So there we go. Now we put a nice long piece of wire on this. As it wasn't FM we were having trouble with, it was AM. Well, let's get the FM going nice first. Give me some reassurance that the radio's generally working. That's a little better. Can't leave it on any music.
A price.
It's not a good thing to do.
No, okay. It's not a good thing to do, absolutely right. Okay. But we do it anyway. Continue to do it.
We should have to do it.
The price of free speech.
So there's FM.
Free speech is a very, very important part of Western democracy, and
pretty good volume.
necessary.
So we'll switch now to AM. Switch to AM, which on this radio is called medium wave. Okay, so we're on medium wave now. Turn the volume up a bit. Okay, yeah, that's better. You can see what's going on with this tube, which is not much of anything. You can see the heaters on there, but I don't see any display. So there is a bit of a display there, but we'll have to check that later. Okay, now it sure seems low, so I'm going to bring on the signal generator. We are tuned to around 900. We're in the range of 900. So we'll take the signal generator output and let's pump it straight into the radio here. Oh, wait a minute. This is not an AM antenna. Let me look at the back of the board. Where's the back of the radio? Figure out which wire's the AM connection. Okay, so here's the back. It's FM antenna here. And then it shows antenna and ground. So the FM antenna is clearly showing a dipole. There's 4 screws here, so it's got to be this lower left screw has to be the AM antenna or shortwave antenna. Maybe not AM. The AM side of this, the broadcast band, may just rely on that loop antenna, period. Should be easy to find out though. How'd that happen? Seems like any one of these will do the trick. Lots of noise. Okay, so we're going to tune my signal generator in. There, you can read the frequency right up here. To 900 or so. Right at the limit of my signal generator band, so I'm going to tune the radio up a little bit here. No, don't turn it up, tune it up. Okay, so now we're at 1000 on the dial. Let's see how close we can come to that. Well, there's somewhere around 1050. That's a little better, eh? I just connected the ground from my signal generator. So let's connect that up more properly. I'm looking for a spare clip, which I don't see. So let's see. We just clip it with any old thing. So now I'm piling quite a strong signal into the back of this radio, which is why it sounds so clear now. So we're going to cut back the signal. In fact, I'm going to calibrate the signal here. Calibrate my signal generator, and we'll actually measure roughly what signal strength is going into it. So calibration procedure is, this has to be here, that has to be there, that has to be all the way up. I make this meter read full scale by adjusting the output. Okay, you're having, I don't think you can see that because of the way the lighting is in the shot. But there we go. You can actually see it. It's full scale now. And that calibrates these controls and this meter. So the output we're feeding out is 1,000 times the meter reading. The meter is reading 10 microvolts. So that means that 1,000 times 10 microvolts is 10 millivolts. 10 millivolts, 0.01 volts on the antenna. Really good radios work in 5 and 10 microvolt signals. So let's take this radio down to there. I can take it down from, I said it was 10 millivolts. We'll take it down to 1 millivolt. Okay, going down, factor of 10 here. Here we go. Okay, so I'll turn it up a bit. So now you're hearing the signal and you're hearing a little bit of noise coming with it. So we're closer to the limit of this radio. And now we're down to 1 millivolt. And is it really 1 millivolt making it to the antenna? I doubt it very much. It'd be something less than 1 millivolt reaching the antenna now. So, you know, that's not insensitive. So, once again, I think I'm just suffering from the shop problems. As we've examined in past videos, all this computer equipment in here generates an awful lot of noise. And the radio, some radios have front ends that just allow noise to get right into the radio. Others have RF stages right on the front end, which will sort of close the door down to a very small amount. So you have all this noise coming at your radio, but only a little bit's going to get through if you have a really good front end. I really think that's the difference, is I bring different radios in here, AM radios, and play them. Some are just overwhelmed with noise, and others sit right here and pick up AM signals quite well. So I think it's all about the front end of the radio. So let's put this on a better antenna, outdoor antenna, and try again, since we now think this is a valid antenna connection. So we'll give that a go here. This one here. Let's do that. So it's easy to switch. I'm just moving a plug down here off the signal generator. That's the outdoor antenna. I'll turn down my signal generator so it won't interfere. And we're hearing AM, so I'll tune a bit. Oh, that's volume. That's kind of funny, eh? I mean, it was receiving one station right where we had it, and it didn't seem to pick up anything else. Okay. That's because I'm tuning the FM, not the AM. Duh. There we go. That really seems pretty good to me. Oh, a little dirt in the capacitor, that's right. Now that's what we gotta sort out. forgot about that. So it looks like FM AM is actually receiving quite well. There's really no problem here with this radio, other than the noisy capacitor, which we can sort out, and the magic eye is not producing any magic. And it only has one light, and it really needs two. So why don't we take care of first the capacitor? We'll make that our objective here. So I need to get good visual access to it, and I don't. I can move this a little bit. I don't want to move it too much, because all these wires I've got hanging around here. Like this one. Okay, that's probably good enough there. Sometimes assessing a capacitor can be a real challenge. So first we'll move it right to where it's just starting to act up. Right on the edge of that. Yeah. The outside plates are always the first ones to be suspicious of. Like that one. Real sensitive. Right down in that area. You can't quite see what I'm doing, so I'll show you a little bit better. Get a little better shot of it. So I'm suspicious that it's this plate here. It's hard to tell, eh? Well, it seems to be the RF part of the capacitor. I'm not even sure of that. If it's the oscillator part, then the radio's retuning each time you hear something happen like that. If it's the RF part, then the radio's getting stronger and weaker. It almost sounds like it's retuning, doesn't it? I guess I could tell if I swung the signal generator around into that frequency. Let's do that. I'll bring the signal generator around. So we're back on the signal generator, and let's see. I tuned over to. Let me. Oh, I gotta do it in this area here. 650, around 640, somewhere around that area. 640. Okay, so we'll go up to 6. Oh my gosh. That's a little curious. That's a little curious. You can see where my signal generator's tuned. I'm not even in the AM band yet, and listen to the signal coming through there. it's definitely retuning. So it's the oscillator portion of the capacitor that's... Well, I don't know, you know. But why 450? Oh, 455. Now wait a minute. Whoa, wait a minute. Yeah, this has probably got a 455. Okay, so that's all that is. I'm just managing to ram a IF signal through the antenna into the radio. So, okay, so that explains that. Ignore that. There we are, just where I thought it was, right around 640. So I want to touch the capacitor now and listen to what the radio does with this signal. It does away with it. That's perfect. Now let's see if I can find it again. Oh, it went totally away. That's not quite what I wanted. You know, this might be the bearing in the capacitor. Sure sounds like plates touching. Let's take a look at this from the other side of the capacitor and see if we can get a little better look at it. Yeah, this might help a bit. Well, it sure seems to be that last plate right there. It's very common for it to be the outside plates. Let's bend that one out a little bit. See if that doesn't clear the problem right there. In fact, come look at this. So if you look very carefully now at these plates, let's see. So you can see this one has been bent out, and that's from a service function. This section has been bent out to change the capacity of the capacitor, but what I see is this second one. Point with a better pointer here. This second plate right here, it looks to me like it's pushed over. This one here. So I'm gonna do that. Try and just pull it back a bit. My first guess. Still doesn't look right. These plates are not meant to be bent. These outside ones are. They're meant to be bent. That's why they're sectionalized. I could see somebody putting a tool in here, pulling this plate over, and in doing that, pushing this plate that way. Okay. Let's see if you got it. The thing about doing these capacitors is analyzing the capacitor very carefully before starting to move stuff and bend stuff. So I really thought it was going to be one of these outside plates. Okay, that's all that took. So we're good on that now.